Okay, so then the last part of this problem-solving question says, then determine the time intervals when the writer could see Niagara Falls. And of course, he or she, the writer, could only see Niagara Falls when they are higher than 50 meters above the ground. Okay, so anyways, we're gonna look at this graph as a reference. But we've got this so far. We've got the equation. We know that y is the height of the rider, t is the time in minutes, and when is the rider 50 meters above the ground? So in other words, what do we need to do? We need to let this equals to 50 meters and solve for t. We need to do that. So when we figure out when the rider is at 50 meters above the ground, then we can make several calculations here in order to find out the interval. Now, I don't know if this question is asking exactly to find the time intervals for each of the 3 cycles when the rider is 50 meters above the ground and they can see Niagara Falls. For me, I would be happy if you could figure it out just for one cycle. If you figure it out for one cycle, you can figure it out for the other 2 cycles or any other number of cycles, all right? So let's work on this. So I would say let y equals 50 meters and solve for t. Okay, so now let's move this up. Basically, we have our equation there. Fine, I'll write it down here so we can all see it, how we apply this. Can we see the equation there? Yes. 50 meters equals to negative 28 cosine, open bracket, 4 pi over 5 t, close bracket, plus 28.5. Okay. Next, we're going to solve for t. So let's start doing that. Let's solve for t here. Let's solve for t. So 28.5, let's move it to the other side. This becomes 50 minus 28.5 equals to negative 28 cosine 4 pi over 5t. All right, what's 50 minus 28.5? So if it's 29, it would be 21 plus the 0.5, 21.5 equals negative, okay, well, equals to this, negative 28 cosine 4 pi over 5 times t. Now let's take the negative 28 and let's move it to the other side of the equal sign because we are solving for t. Cosine 4 pi over 5t. So what happens here? So now, of course, now I grab my calculator. 21.5 divided by 28 equals to 0. Okay, I have to 4 decimal places, and there's a negative there. So negative 0.7678. Okay, let's put 79. Since it's 85, 79 equals to cosine 4 pi over 5t. Now, how do we solve for t, in case you're wondering? Well, treat this whole thing as though it was one value, as though it was theta, right? And so normally, what do? Cosine inverse of this. So we do cosine inverse of 0.7679. 7679 close bracket equals to 4 pi over 5 times t. And now let's put this in the calculator. Now we're using radians, so I want to make sure my calculator is in radians, and in fact is in degrees. Okay, now it's in radians. So we do cosine inverse of 0.7679 equals 0.695, okay, up to 4 decimal places. 0.695 2 equals to 4 pi over 5t. Hold on one second. You guys notice what happened, right? I forgot to put the minus. That's important. So, guys, once again. Sorry about that. I know it's a video. It's kind of like rushing a bit. Okay, let's repeat that part again. Cosine inverse of negative 0.7679. So let's do that. Let's put that in the calculator. Make sure it's in radians because we're dealing with radians. And then we start again. Cosine inverse of negative 0.7679. Okay, now this is starting to make a little more sense. 2.446364. So 2.2464 equals to 4 pi over 5t. And now how do we solve for t? Well, let's isolate t. So they take 4.5 over 5, move it to the other side. So this essentially becomes, we can also look at it this way, 5 times that divided by 4 pi, pardon. So let's do that. So this becomes 5 times 2.4464 over 4 pi equals t. Now what is this going to be equal to? So I have that already there. Times 5 equals divided by 4 pi equals 0.973. Okay, so 0.97, so t is equal to 0.97 minutes. But let's round it off. Let's round it off to 1 minute, just so that it makes it easier to calculate to make calculations easier, right? So 1 minute, basically, round it off to 1 minute. Now, the question said, when does the rider reach 50 meters? So if it's 1 minute, let's go back to our graph. If it's 1 minute, we could say it's somewhere over here, right? Somewhere over here we have, I hope you guys can see this. Somewhere over here we have 50 meters. Let's say it's that. It's a sketch. And over here we have, oh, well, it's a sketch. Over here we have, I should have put this a little bit higher so that it makes, I know it's a sketch, but at least let's try to reflect real life. So it's actually closer, okay? That's 50 meters. That's 50 meters, okay? Right there, that's our 1 minute mark. This would be 1 minute, 1.0, okay? Right? So there, after 1 minute is above 50 meters, and then once it starts going below, that will be another one, right? So that's the interval. So what is this interval here? What is this interval here? Well, this interval is going to be what? From 1 minute, so it's about 0.25 minutes away from this mark. So at 1 minute and a half, it would be the end of this interval, right? So at 1.5, it will be the end of this interval. So that means the time t here is what? Bigger, can you guys see this? Bigger than, yeah, just bigger than, because once it goes above 50 meters, then you can see Niagara Falls. So just bigger, not bigger than or equal. So bigger, when t is bigger than 1 minute and less than 1.5 minutes, then we can see Niagara Falls. So that's our answer right here. Okay, that's our answer for this. Okay, so let's just formalize it here. And I just wanted you to get this for the first interval, okay? Alright, so now let's go back here. Then we can say just therefore, you know, by inspection, you can say therefore by inspection, you know, once we got this 1 minute, by inspection, the time interval for the first cycle by inspection, the time interval for the first cycle when the rider is above 50, when the rider is 50 meters above the ground, when the rider is 50 meters above the ground is, and so we can say between 1 minute, so when t is bigger than 1 minute and less than 1.5 minutes. And that's all.